Well, we talked about the water cycle. And once again, what did we say? We said matter cannot be created or destroyed. Matter cannot be created or destroyed. What does it do? It changes forms. So we talked about the water cycle. We said we've got all this water, the same amount of water as the day the earth was created. No new water, okay? So it's all tied up in this water cycle, all right? Well, guess what? It's not just water that's no new material. It's oxygen and carbon dioxide. Now, remember we talked about earlier the three main chemicals, not only in humans but on the earth, okay? Especially in living organisms, the three main chemical elements, okay, are carbon, okay, chemical symbol C, oxygen, O, okay, and hydrogen. All right, so H. So these are the three most abundant, three most important, three most critical, the three things that we have to take a look at. As a matter of fact, we have a whole chemistry devoted to those three. It's called organic chemistry. Organic is living. Okay, anything that is living or has ever been living contains carbon. Okay, anything that is living or has ever been living contains carbon, and that's important to know. That's important to know as we talk about the oxygen and the carbon dioxide cycle. So let's put that in here. Okay, so carbon. All right. So anything that is living or has been living contains carbon. Not only contains carbon, carbon is the main building block that it's made up of. So what about paper? Paper's not living. Well, paper comes from a tree that was living. Does paper contain carbon? And the answer is yes, paper contains carbon. Now, what about plastic? Plastic's man-made. Does it contain carbon? Well, golly, I don't know. It's pretty solid. It might. No, it doesn't contain carbon. It's artificial. Oh, that's interesting. Anything that is living or has been living contains carbon. Now, does that mean that we can't take some carbon out of living things and put them in others? No, it doesn't mean that. But as we look at carbon, we know carbon is living. Okay? So, living, okay, the word for living, now this is where we're going to kind of talk about organic here a little bit, okay? So, the Latin word meaning living, which means in Latin means contains carbon, okay, you see what I'm saying? We talked about the importance of carbon. We're fixing to talk about oxygen, carbon dioxide cycle. We're fixing to talk about the carbon cycle itself. So carbon, okay, meaning that anything that is living, okay, the Latin word living, which means to contain carbon, guess what it is? You've heard this term, and we're hearing it more and more in our lifetime. It's organic. Okay? Organic. All living, all natural, not artificial, not chemical, okay? So if you go to the store and you're going to go in there and you're going to buy a bunch of lettuce or a bunch of something that's organic, what does that mean? It means they didn't use any chemicals on it. It means they didn't spray it with a chemical herbicide to kill weeds, and they didn't spray it with a chemical pesticide to kill insects, okay? All right, and it means that the fertilizer wasn't a chemical fertilizer that contains phosphates or whatever. Everything's living. Now, unfortunately, that phosphate might be, or that organic fertilizer probably is manure. Okay, it's probably manure. Just a little side note, a little TMI that you probably didn't want to know. In the United States, okay, now you're going to be like, oh gosh, Mr. Anderson, don't tell me, I don't want to hear this. But in the United States, you cannot use human fecal material for fertilizer, okay? Because of the bacteria, because of the viruses, the different things they have in it. However, in a lot of other countries, it's okay, and not only is it legal, it's a common practice to use human fecal material, human manure, human poop, okay, to fertilize the crops. Now, what happens is whenever human fertilizer is there, that's when we get fecal material. We're like, how can we get salmonella, okay, which is a bacteria that grows grows in humans and that type of thing. How can we get it on our lettuce? You know, oh my gosh, the store has salmonella, or it has whatever kind of organism on it. Somebody probably, first of all, we used to get stuff from other countries that used human manure. That's a good way to get that on there. Or, believe it or not, it could be as simple as the people working with it that harvested it, that cleaned it, at the store, that they didn't wash their hands. So somehow it had to come from, there's certain types of organisms that have to live in the human body to be able to grow, and then we pass those on through fecal material. Way too much information. But that's why people are saying, you know, organic may be better. Now, is it worth the extra cost? I don't know. You got to decide that for yourself. Okay, so carbon, oxygen, and hydrogen. So now we're going to go on and we're going to talk about, we get a lot of stuff up here, okay? It really looks like a good college board here, okay? We're going to talk about the oxygen carbon dioxide cycle. Now, we've even mentioned a little bit about the CO2 and the oxygen. We're going to go a little deeper, okay? We're going to go a little deeper. So what do plants do? Okay, what do plants do? They take in carbon dioxide. Okay, so plants take in carbon dioxide and give off oxygen. Okay, so plants take in carbon dioxide and give off oxygen. Now, what's that process called? Okay, we know what that process is called. That process is called photosynthesis. Okay, so plants carry on what we call photo, meaning light. Okay, synthesis meaning to make. Okay, so plants in this chemical process of photosynthesis, they take in the CO2. Okay, they take in the CO2 from the air. Okay, and they give off the O2. What is O2? That's oxygen. Okay, now once again, it's O2. Now let's talk about that for a second. What's the difference between oxygen and O2? An oxygen molecule by itself, okay, is very flammable and actually very explosive. But if you combine it with another oxygen molecule, it's stable. And later on, when you take chemistry, you'll learn the Lewis dot structure. You'll learn how you fill the outer valence electrons, and you make this stable. So an O2 molecule is how our oxygen exists in the atmosphere. So our atmosphere is full of O2. So when we say atmospheric oxygen, and what kind of oxygen do we breathe in? We breathe in O2. Okay? O2. Diatomic. 2 atoms. So oxygen in the air is diatomic, meaning that there's 2 atoms, O2. Okay? So when we breathe in oxygen, we're breathing in O2. We're breathing in O2. Okay? Now, I'm going to go one step further, and I'm going to show you a third one. Okay? We have another area where oxygen can actually form a third bond here, where the outside electrons share the electrons. It's kind of cool. So we have O3. Okay, O3. Now, what is O3? It is 3. When we have 3 or more, it's called polyatomic. Okay, but O3 is ozone. Okay, so we hear a lot about that. We hear a lot about the ozone layer. We're going to talk about that here in a little bit. But the ozone layer is when we have all this oxygen in the air. We have extra oxygen. We're going to talk about how ozone forms. Okay, one of the great things that happens is when we have these extra oxygens up in the sky, and we have nitrogens and we have water vapors. We have a lot of ozone in the air. Lightning hits, and when lightning hits, lightning busts up and releases this extra oxygen, okay? And then it combines with extra hydrogens, and the water begins to form perfect H2O, and it comes out of the sky. That's when lightning hits, we begin to get these charges evened out to where they equal 0. When lightning hits, we clean the air. We clean the air. All these charges that are there, that's why lightning lights up, because it's electrical charges. All the plus charges and all the minus charges. All the junk that's in the air, all the water, when the lightning hits, it pulls all those charges off. So what happens on this water molecule, this H2O right here? When we take the charges off, then we have pure water. What do we have when we have pure water? We no longer have a gas of water, we have pure water. What do we get? Oh, we get rain. That's why lightning is associated with rain. Okay? That's why lightning is associated with rain. Could we have rain without lightning? Yes. That means that the water up in the sky is pure water. We don't have the charges, okay? But if the sky is full of charges, the lightning hits, pulls the charges out. Remember, matter can't be created or destroyed. Where do the charges go? The charges go towards light and sound. They make the light of the lightning, okay? And they make the sound of thunder, okay? We'll talk about, and that's in a chemistry class. We'll talk about, well, then where do they go from there? What happens, okay? So, what happens? Plants, through the process of photosynthesis, do what? Take in CO2 and give off O2. All right? Now, animals, okay? So once again, do plants contain carbon? Yes. Do plants contain hydrogen? Yes. Do plants contain oxygen? Yes. So what's happening here, okay? So we're remixing the plants in the photosynthesis are taking the CO2, taking out the carbon, and giving off the O2. What are animals doing? Animals don't work on photosynthesis. Animals work on what we call respiration. Okay? So what is respiration? Respiration is where, in respiration, what do animals do? They take in O2, which is the atmospheric oxygen, and they give off CO2. Okay? So that's respiration. So respiration is take in O2 and give off CO2. Okay? What does photosynthesis do? Photosynthesis takes in CO2 and gives off O2. Okay? So where's photosynthesis? That's in plants. Where's respiration? That's in animals. Now, but this cycle is going on constantly. Now, is this the only oxygen in the world is just between plants and animals? No. No, it's not. Even though we go over here to this water cycle, what else is up in the sky? Oh, where's this oxygen? Oh, it's tied up in what? Water molecules. So now, as part of the whole process, a bunch of the oxygen is tied up in the atmosphere in the water cycle. It's tied up in there. It's even in the ground, in the water. So we have oxygen and here we have carbon. So where's the carbon? Is it all in the animals and the plants? Well, we're going to do the carbon cycle here in a little bit. We're going to find that carbon is all throughout the earth. Okay? So we're going to talk about that next. But we need to know that the oxygen CO2 cycle is critical. One of the things that we just kind of talked about in passing before a little bit in this is that a neat experiment in early years was to take and you can even do this yourself. I don't know that I don't know if you should sacrifice a gerbil to do this, but you can get a big jar. Okay, you can get a big jar and plant a plant. Okay, plant a plant and put a little mouse in there or a small animal, a lizard or something, and seal it up. Even glue the top, and for days, months, and they've even had the perfect combination to where the animal is giving off CO2 and taking in oxygen, and if the plant's doing the same amount, they can continue to live. Now, I don't want you to do that and kill the plant and kill the animal, so try it for a day or two, okay? Try it for a day or two, and don't push your luck, all right? But if you had just the right combination of plants and animals, which is what we try to have here on Earth, that's what we have to watch. Or we're going to take out too many trees that we don't have enough oxygen. We're going to talk about some more of that in the next video when we talk about the carbon cycle. Believe it or not, I want to tell you this. Guess what else on oxygen? We found this out within probably the last 5 or 6 years. It's incredible. There's little microscopic plankton and zooplankton that live in the ocean. And we found that 40 to 50% of the oxygen in the atmosphere is actually coming from the zooplankton and the phytoplankton in the ocean that's actually being lived off and breathed off and given off, going through the ocean and then going up into the atmosphere. Isn't that amazing? Well, we're going to pick up with the carbon cycle next. See you then.